Hello, everyone. We are working on statistics, Unit 5, Lesson 3, sample space. I'm doing some sample space today. We have a learning target here. Determine the sample space for a chance experiment. So we're just, let me get this over here. There we go. We're determining the sample space for a chance experiment, which is like the universal set, so to speak, to connect it back to what we were learning with set theory. All right, so here, we're going to roll a die. It's a six-sided die. All right. What are the number of possible outcomes we could get? What are the possible number of outcomes we could get? Well, we could roll it, and what? It could roll a 1, it could roll a 2, a 3, a 4, a 5, or a 6, right? So there are 6 possible outcomes. Our sample space is 6. There are 6 possible outcomes of rolling a six-sided dice. I should say die. When you only talk about one of them, it's a die. When you talk about 2 or more of them, they're dice. All right, tossing a coin. Tossing a coin. You flip a coin, right? What are the total number of outcomes in the sample space? Well, in this case, it's really easy to tell. It's 2. We don't really need to write out the possibilities, but sometimes it's helpful to think about all the possibilities before you think about the sample space. Like, right, it could end up heads. It could end up tails. Those are my 2 possibilities for the outcomes of sample space. And I don't know how much you play cards. Maybe you've heard of this game called 52 Pickup. There are actually 52 cards in a standard deck of cards, plus or minus some jokers, right? So there's a joker or 2 in there. And what's the sample space of spades? Maybe you want to think about that. Pause the video here. What will be the sample space of just the spades? And I don't know how much you know about cards, but there's no one card, but there is an ace. There is an ace card. There's a 2 of spades, a 3 of spades, a 4 of spades, all the way up to 10. And there's also, you get into the face cards, right? There is the jack, the queen, and the king. All right, those are the face cards, the jack, the queen, or the king. All right, and then they're going to ask, like, what's the sample space of the clubs? Well, if you know anything about cards, you know that that's going to be the same, right? Each suit has the same cards in it. All right, so there are 4 suits of spades, clubs, diamonds, and hearts. You just copy and paste these in here. This is the sample space for each suit. All right, pause the video if you need this. Moving on. All right, drawing 1 marble from the bottle. Drawing 1 marble from the bottle. What there will be how many marbles in the sample space? So tell me how many marbles there'll be in the sample space here. Pause the video, think about it. All right, I'm hoping you said 8. All right, I think there's 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 possible marbles. And let's think about this sample space. I could either get a red marble or a blue marble. And in this case, you know, we're going to say that we can identify which marbles are which. So I can get the first red marble, red 1, or I can get the red 2, or red 3. All right, and I can get blue 1, blue 2, blue 3, blue 4, blue 5. And that's it, right? Yeah, 5 blues, 3 reds, 8 total. This is my sample space. All right. Now we're going to roll a pair of dice. We're going to roll a pair of dice and add up. We're going to add up the outcome. So think about what are the possibilities here? Think about what's the lowest number you could get if you roll 2 dice and add them up? What's the highest number you could get? Roll 2 dice and add them up. All right, if you think about the lowest number, hopefully we're thinking, well, I could roll 2 1s, right? I could roll 2 1s, and 1 plus 1 is 2. So my lowest number I could possibly get is a 2. What's the highest number I can get? Well, I could roll 2 6s, right? And 6 plus 6 is 12. So 2 is my lowest number, 12 is my highest number, and I could get everything else in between, right? I could roll a 1 and a 2 to get a 3. I could roll a 2 and a 2 to get a 4. I could roll a 3 and a 2 to get a 5. I can get a 6 by a 3 and a 3, a 7 by a 3 and a 4, an 8 by a 4 and a 4. I could get a 9 by a 4 and a 5, a 10 by a 5 and a 5, and a 5 and a 6 will give me an 11, and then I'll get a 12 with a 6 and a 6. That's my sample space right there. How many possible outcomes are there here? There's 11, right? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 possible outcomes in the sample space. A lot of times, it's going to be easier to just list out, just list all, oh, I don't want to move all that around, just list out the possibilities, just to list all these things, and then count how many possibilities you have to get the sample space. All right, we're going to choose an outfit from a green blouse, a red blouse, a black skirt, a pair of sneakers, and a pair of sandals. All right, let me think about this. All right, we're not, in this situation, we're not going to have two pairs of footwear on at the same time, and we're not going to have two blouses on at the same time. All right, so there is the possibilities there of blouses. You can choose green blouse or red blouse. Of skirts, there's only one choice. There's the black skirt, and then of footwear, there is sneakers SN or sandals SD. I'm gonna abbreviate, make life easier on myself. What are my possibilities? I could have one combination. Let's say I start with the green blouse, I put on the black skirt, right, and then I wear the sneakers. All right, that's one possible combination I could have here. Alternatively, the person is wearing a green blouse with a black skirt, and then sandals. Right, they could do the sandals this time. What's another possible combination of clothing they could wear within these options here? Well, we've exhausted all the possible options we have with the green blouse. All right, so now we have to move on to the red blouse. Red blouse. I need to be in there. Black skirt, sneakers, or next time they could do sandals. Right, red blouse, black skirt, and sandals. Really, what I'm left with here after I look at all the possibilities is four. I have four possibilities. There's four possible outfit combinations in my sample space. All right, let's see. There's the one. There's the second. There's the third. There's the fourth. I don't have any other combinations available to me. So there we go. Pause this if you need it longer. Moving on to the next piece. When attempting to determine a sample space, the sample space is the possible outcomes from an experiment. It is often helpful to draw a diagram which illustrates how to arrive at the answer. One such diagram is a tree diagram. It looks like this. All right, and in this example, we're going to show the sample space for tossing one penny and rolling one die using a tree diagram. Okay, first the penny. We're going to flip the penny. What's our sample space? It's heads or tails, right? So we could, hey, okay, they flip the coin, and there's possibility is heads or tails. Now they're going to roll the die. They're going to roll the die, and what's the possibilities there? Well, they can roll a 1, they can roll a 2, a 3, a 4, or a 5, or a 6. And then if the penny goes heads, still the die is going to do a 1, a 2, a 3, a 4, a 5, or a 6. All right, that's what a tree diagram looks like. Sorry, if you needed that longer, pause it. I'm going to go on to slide 7. And here we are at slide 7. The Grimaldis. The Grimaldis are going to have 3 children born different years. All right? So they want us to draw a tree diagram or list the sample space to show all the possible arrangements of boy-girl combinations in the Grimaldi family. And unfortunately for this, it's 2020. And unfortunately, we're going to assume a gender binary here, which is unfortunate. But for the sake of math and simplicity here, we're just going to go ahead with that. Let me try. I'm gonna click make a text box, and then I'm gonna give it a border weight. Where's my border weight? There it is. There we go. There's a nice border weight right there. I like it. When I copy, border weight 4. Where's my border weight again? I lost it. It's over here somewhere. There it is. There we go. Now I gotta make these kind of far apart. Put him and them. All right. So now I'm gonna copy. I'm gonna paste. Okay, I need to move this. All right. Either there or there. Either there. There. And now I can I'm going to select. Okay. You saw, what I'm trying to do, I'm trying to create the makings of a tree diagram here. You don't need a tree diagram, but, for the sake of demonstrating this to you right here, I'm going to do that. And now I need a whole bunch of lines, don't I? I need this, and this, and now I will do. Takes up more time than necessary. My apologies. Oop, I didn't want that. There we go. Actually, I'm going to move it over. There we go. There we are. Go. It's easier to use the arrow keys sometimes. And I'm learning this. And then, oh, I'm going to need to make a little adjustment for that one. All right, we've got it now. So their first child. What's our two possibilities, right? With the unfortunate gender binary assumption, there's a boy or there's a girl, right? And then so that's their first child. That's the possibilities for their first child. The possibilities for their first child was either it was a boy or a girl. What's their if their first child was a boy, what's their possibilities for their second child? Well, it was either a boy or it was a girl, right? If their second child was the first child was a boy, and their second child was a boy, what's the possibilities for their third child? Well, it was either a boy or it was a girl. All right, and you're just going to complete this chart, right? Each time it bifurcates, which means goes in two different directions. Boop, nope. It seems simple, but I can still goof it up. It's fine. Then tree diagram needs branches. Tree diagram needs branches. All right, let me talk about what are my possibilities. So normally I would do something like this. I would go squiggly bracket B comma B comma B. But if I go ahead and do that, I'm going to be hurting my fingers with commas in squiggly brackets, and it's going to be a lot. So instead, I'm going to make it easier on myself. I'm going to go B B B. All right. All right, that's one possibility. There's one possibility that they had a boy on their first child, a boy for their second child, a boy for their third child. It's also the second possibility is that they had a boy for their first child, a boy for their second child, and a girl for their third child. That'd be BBG. It's a possibility that they had a boy for their first child, a girl for their second child, and a boy for their third child. So that'd be BGB. At this point, I'm going to have you finish the possibilities here. You want to pause me and finish this up? Great, through the magic of pausing, you have finished this up. Girl, girl, boy, and then girl, girl, girl. All right. When I have completed my list, I've got 8 possibilities, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities. And I also notice I have 8 boxes at the bottom here, right? There's also 8 This represents a number of possibilities that it bifurcates to. Using the information from Part A, what is the probability that the Grimaldis have girls and boys? All right. So this kind of question is saying what is the probability that they will have a combination of children where there is at least one boy and there's at least one girl? Think about that. Pause the video here. All right. To do this, we need to think of, well, how many? I know there's 8 possible combinations. 8 possible combinations. How many of them include at least one boy and one girl? Well, let me look at this set. Well, that includes just boys. So that's out. It doesn't count. I can't count that one. And then I've got this set over here. It's all girls. That's out. It does not have at least one boy. So I need to count only the sets that have at least one boy and one girl. And there's one right here. Right, that counts. It's boy, boy, girl, boy, girl, boy, boy, girl, 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 boy, boy. So I have 1, 2, 3, 4, 5, 6. 6 possibilities out of 8. There is a 6 out of 8 chance that the Grimaldis will have at least one boy and one girl. All right, there's 6 out of 8 chance, right? What about that? How do we put that into a percentage? How do we put that in a percentage? Maybe pause the video here. Think about how you put that in a percentage. All right, this is magic. You've unpaused me, so we could do 6 out of 8. Well, we could reduce that. It's like we could do 6 out of 8 like a fraction. We could express it like a fraction, and we could reduce this fraction down. That would be 3 out of 4. Right? Divide the numerator and the denominator by 2. We get the equivalent fraction called 3 out of 4. And what is that expressed as a decimal? Right? If you put that in your calculator, 3 out of 4, it'll be 0.75. And we can change that. This is basically a percentage expressed as a decimal out of 1. We can express this as 75% by multiplying it by 100, right? Because a percentage is a percent. It's out of 100%. This is a percentage expressed as a decimal out of 1. So 75%. There's a 75% chance that the Grimaldis will have a combination of children with at least one boy and one girl. All right, and that is where we're going to end for to Monday. All right, so I'm Mr. Salt, and I hope to see you in class.